This is Alim Bargato from Javelin Technologies, and this video it's all about creating some crazy blends between two complex surfaces. And we have to thank Galen Werner for challenging us on the SolidWorks forum to do just that. You can see the part that he created here, and originally he was looking for adding some type of fillet, like a 4mm fillet around its edges, but really he wanted a blend, a nice blend. Fillets would not work very well. Maybe that's a topic for another video. Once we finished, we had the starting point and the finish point. So you can see here, the goal was to create something, a bunch of faces that will have at least C1 conditions of tangency throughout. So you can see the zebra stripes are matching pretty nicely around the edges, across the edges through the blended face. And we did it pretty fast. And this video, it's all about one of the techniques to get this job done. Of course, this can be further refined. The main problem with this part is the big disconnect between the topology of the two faces. You can see edges on a group of faces that are not really matching edges on the other side. Fillet is going to have trouble. Blends would have trouble. The other thing is if you show the fabric of these faces, so let's maybe turn on the face curves, and probably the best thing would be to start with a 3D sketch to do that. You will see that the faces are kind of independent, cut from independent pieces of fabric. So let's go here, maybe a 10 by 10. Okay, you can see this this grid on this face. Let's do the same thing for this one. So you can see there is no matching. No surprising because the tools that he used were creating faces one by one with different features. And you can see there is absolutely no matching across. So the fillet was going to have lots of trouble trying to trim the surfaces consistently. Now, even if you try to use other techniques, the biggest problem would be to create the original edges from which you're going to start the blend on both surfaces. So let's try to achieve just that. This is the purpose of this video. If you find it interesting, please keep watching. As I mentioned, the goal is to create the edges from which we're going to start the blend. So let's maybe trim these faces by an offset of these two faces with about 2mm. First, though, I just want to have a comment. You can see there is a fillet at the back of these faces. So even though it's not apparently connected to the blend that we're going to create, it will actually be connected right here at the end. And this is going to create a big headache. So let's suppress this fillet for the time being. The other thing we will do, we will color this solid body to keep it distinct from any reference geometry we're going to create. So let's pick maybe the yellow color. Notice also this two faces created by this feature have a gray color. And there you go. That's the initial body from which we start. So the goal is to find out where this face has been created. We're going to take advantage of the fact that this is a SolidWorks part. I don't have to do reverse engineer. Just simply going to roll back. And looks like Surface Extrude 3 is the one that created those two faces. So let's run an offset surface with 2mm to the outside. And let's come back to the present again. So roll to end. Next, let's isolate the faces that are going to be part of the so-called fillet. So all these faces are going to take part in the operation. And I'm simply going to copy them with offset 0 or with the neat feature. Let's be consistent. We're going to use offset. At this point, I can hide the old solid body by simply moving my mouse over any of its faces and pressing the tab key. You can see I have two surface bodies. Let's run the trim command. Standard trimming, this is going to do the trimming, and I'm going to keep the upper area of the surface body. And at this point, I don't need this body anymore. Let's delete it. But remember, you're going to delete a body, not the feature itself. So you can find it in the feature manager. You can right click and look for the body area of the right mouse menu to find delete body. You can also press F5 to turn on the filters and use the body filter, then select the body. I mean, there are multiple options that we can use. Sorry, this is a surface body filter, not solid body, right? I'm selecting this. And now when I'm pressing the delete key, I'm using the delete body command. So a nice way to clean this up. Let's turn off the filter and bring back the original solid body. So I'm going to press Shift Tab in this space, and you can see it came back. The next thing I would like to do is to copy or create an offset of these edges about 1 mm on these faces. And fortunately, SOLIDWORKS now has the offset on surface command, which allows me to select edges and pick a direction. Right, so you can see I want this one and this one. I'm going to run this command for each face at a time. So there are 2 faces. This is going to be 1. The moment you do it, you are inside the 3D sketch. So that makes things easier. Let's do it here too. This time I want to select all the edges from this edge. And again, to maybe here. So how do you select all the edges between 2 edges? You simply select the first one, Control select the second one, and use the option select partial loop. Make sure that the selection happens closer to the direction from which the chain of edges is coming from. So I selected all of them. I'm using that in case there is somewhere a really, really small edge that otherwise would be next to impossible to select. So let's run again, offset on surface, and we have this done. Now, don't expect these guys to match, okay? Because depending on how this is measured, you might get the distance measured on the surface or distance measured the shortest way, right? So notice I have 2 options here. I have the Euclidean offset or geodesic offset. So in this case, none of them is going to make these two to match. So for now, I'm going to leave it like that. Let's do it one more time for the last edge. Okay, so you can see it's right there. Now, it's time to clean this up. Before I do that, allow me to save this. And I'm going to go back again one more time in time when this face was created, which was this one. I'm going to do another offset, a copy of these 2 faces. You're going to see in a moment why I'm doing that. Now, when I come to the present, I can hide again the body. So we tab, and you'll see when I'm going to edit this sketch, I can use this new face to place some type of geometry in here. So for example, I would like these 2 points to move, right? So notice I'm detaching them, similar to the offset in a 2D sketch. Why? Because I would like to create this type of edge on this area over here and give me something that I can play later on. I can adjust by moving this, right? So let's use a spline on surface. And this is the reason why I wanted to create this extra body. Notice what happened if I don't have it. I'm just going to bring back the solid body. I have this ridge. So if I don't have that surface body, let me hide it for a second and bring the surface body, the solid body. If I try to do a spline on surface, see what happens. So if I use the option spline on surface, let's pre-select the face first. So spline on surface. And I'm going to say, hey, let's go from this point. Notice what SOLIDWORKS does. It's actually doing a pretty good job of taking into account all the faces that are involved there. So it's going to go up on these faces, which is not what I want. So that's the reason why I don't want to see this body. I want to see just the surface offset. So let's delete this spline and try to recreate it this time on this surface. And you're going to find out it's not going to be easy if you want to have tangencies to the other 2. SOLIDWORKS 3D sketches require a really complex constraints or calculation of constraints internally. So let's see if we're going to be successful. I'm going to start with a spline on surface and see what I can get. I'm going to go from this point with a 2-point spline and see if I can apply things like, I don't know, maybe equal curvature. And you can see how he's trying to do, but it can't. Let's undo this. Let's try tangency. Looks like tangency is possible here. Let's try on the other side again, maybe tangency only. Doesn't want to do it. Undo. Let's try equal curvature. And in this case, it's possible, which is kind of unexpected. So it's kind of interesting. You can do C1 here and C2 there. Okay, let's leave this spline where it is for a moment and focus on the other side where we have this disconnect between those edges. Also here, I'm wondering if this sharp point is going to give us grief. And I'm not sure. So let's try first to get them to match. For that, I'm simply going to delete the offset for one of them. And notice the moment I did that, the whole 3D sketch is acting up. But to my surprise, I'm still able to move things around. So for example, if I want to make this merge, let's see if I can actually just drag it on top. Seems to get connected there. And I can even attempt to apply a tangency across that, that edge. It makes it a little bit strange that I can do this work in with all this error popping up, right? So theoretically, if I am to go here and maybe suppress some of these relations, let's see if I can go directly to the suppress command, which I hope you guys know you can suppress entities at the sketch level. You don't have to go only outside. Notice that it seemed that this works, this one doesn't. So again, this tangency should go. And I'm gonna probably have to leave with this solution for the time being. Or the other thing I can do, I can get rid of this completely and draw another spline on surface. We know the starting point, we know the end point, and try to see if I can apply relations. Right now, this is actually black. So that kind of tells me it would be dangerous to apply a tangency at this point. But actually it worked. So the tangency worked there. I think it would be a bit foolish to attempt to apply a tangency here, but we can try. And to my surprise, it actually worked. And it worked pretty nice. One thing you can do, you can move this point in across the face. So let's see if I can drag it. Looks like I cannot really drag it right now. Allow me to undo the application of the last relation and try to drag it now. You can see I can drag it pretty much on the offset of the 1 millimeter offset. So one more time, try to apply a tangency at this point. And notice how here it doesn't work to do. So you know what, I'm gonna leave it the way it was before, kind of like that solution for the time being. And we'll see if this will create problems or this is something that we can use. Okay, those are some of the options that that we can use. The other thing I could have done, so let me just save the sketch in case we want to come back to it. Let's edit the sketch one more time. I'm pretty sure many of you are going to have lots of comments about how you can do this even better, and I'm more than happy to learn those. So the other thing I can do, I can get rid of this completely. And I'm going to say, yeah, this point is going to be here. Let's build another spline on surface. Sorry, spline on surface between this point and this point. Apply tangency here and tangency here. All right, so you can try to do this. So I have this edge will correspond to this edge. This edge will correspond to this edge. Okay, so options, and then we have a point that we can drag anywhere we want in order to modify the quality of the resulting blend surface. Let's try one more time here to try to unsuppress this tangency. Let's see if I can simply select it for unsuppression. And it worked. There you go. Good. So that's our sketch. Remember that we built this surface body just in order to be able to create this part of the sketch. So now it's time to delete the body or hide the body. For the time being, I'm not going to focus on deleting. I'm just going to hide it. Let's bring back the actual solid body, offset 0. So we use the divide and conquer principle, where we simply create simple subsets of faces for trimming purposes, blending, and almost like reverse engineering. Let's do a little bit of trimming. This time the 3D sketch is going to do the trimming. I'm going to try to keep this side. You can see right now I have, oops, actually before I do that, we need to clean this area up. So my bad when I run the offset. Okay, we need to clean this up. So let's try to run the untrim command on this edge and this edge. Okay, I think I'm happy with that. I'm going to use the option connected endpoints. So now when I do the trimming, you can see this looks beautiful. That was probably the hardest part for now. Now, let's start working on creating the blend. You can use boundary. It probably would make sense to use boundary on loft because you have two distinct conditions. But I'm going to do something that goes against most of the best practices. I'm going to use the fill surface, even though I'm going to create 4 edged or 2 directional surfaces. So let's start by building a 3D sketch that contains a spline that would connect these 2 points. Let's apply tangencies. Now tangencies can be applied to these edges, right? So I can make this tangent to the edges, or I can make it tangent to the face. So let's see the differences between the two. If I apply tangency between these two, it doesn't necessarily mean that this is going to be tangent to the face. Okay, so that's one thing to consider. Let's do it the same here, but in this case, I'm probably okay with applying tangencies to the edges. So let's see if that makes sense for now. One thing I would like to see on this spline, if it has any inflection points, so it doesn't, right? You can also check that with the curvature. You can see the curvature goes in one direction only. So I don't have concave and convex areas at the same time. I'm going to leave every profile in its own sketch. So let's create another sketch with another spline. And let's see, where is the edge? I'm going to go up to here. Same thing, I'm going to try to apply tangencies to the edges for the time being. Here I don't really have an edge. So what I'm going to ask SOLIDWORKS to do is to go and apply a tangency to this face. So notice if I select the spline, the edge, and the face, and I decided to use this edge instead of that one, you can apply tangent to face. Again, let's take a look at the inflection points. No difference. Would you be curious to see what happens if I select this edge for the tangency? So let me create another spline between these 2 points. Select this one, this edge, and the face. Run tangent to face. And you can see I'm getting a different solution. So this is also tangent to face, but it's going to be based on this edge, kind of going in this direction instead of going in this direction. Which one would make more sense for us, right? I'm not sure yet. Let's turn this to construction geometry for the time being, and I'm going to base myself on the direction given by this edge. So let's run the fill surface. You can also try with boundary. So this is going to be a long video if I try all the options. I'm just going to go with fill. So these two are going to have contact. This is going to have tangency. And this also tangency. Also, this option optimize surface, I usually like to have it unchecked. That's going to enable the surface to be cut from a bigger patch. If you're looking at the, if I have here the mesh, you can see how this one goes with optimize on. It's actually based on the direction of those edges, while here it's cut from a very relaxed patch. Okay. let's leave it like that for the time being, see if it works. Good. Let's create the next one. So do I have an edge that finishes here? I do. So another 3D sketch. I'm gonna go from this point to this point. Gonna apply tangency here. And here I'm gonna go to the next face and the next edge, just to be consistent to what we did before. So tangency, and that's my sketch. Let's run again, fill surface. Again, don't hesitate to test the use of boundary instead. So here I'm going to have tangency, and everything from now on is also going to be tangency. Okay, turn off the optimize. And actually at this point, would be interesting to see, we're also going to run with optimize on, because I have a feeling if we have optimized for both of them, the face curves are going to continue nicely across, but I might be wrong. Let's try though. So I'm going to have optimize here. Let's edit the previous one also and apply optimize. And let's show the face curves. So I'm just going to create a 3D sketch. That's going to allow me to have all the face curves in one sketch, right? So that's going to be one. Let's go 5 by 5. Okay. And this is going to be the second one. And you can see actually in this case, I would probably prefer optimize because it creates a nice mesh across. It's going to be very nice, beautiful. So that's what we're going to do. Okay, let's keep going. Here I have a bit of a problem, but there is an edge for some reason. Whoever created this, there is an edge there. So we can use that one for creating an extra edge. Now you might be tempted to really create big surfaces in one go. You can try that. I find out that divide and conquer, especially for this type of blends, works really well. So let's try again. 3D sketch, spline, tangency here. So this and this tangent. And in this case, again, I'm going to go to the next edge to apply the tangency to the face. Let's be consistent. Fill surface, tangent from now on. Okay, I'm going to try to use optimize. Let's take a look at this. I'm a bit concerned to what I'm going to see here. Doesn't look that good. If I turn off the optimize, you can see that in this case, it's a much more relaxed surface. So I think I'm constraining it too much with optimize. So the result is going to be ugly. You can see this bump. So again, apply common sense. Right, so in this case, I'm just going to turn off optimize. Unfortunately, I'm losing that continuation of the patch, but the surface is much nicer than otherwise. Okay, let's take a look here. I see a point here that seems to correspond to this one. Okay, so another 3D sketch with a 2-point spline. Notice I'm trying to keep things simple. Tangency. And again, I'm going to go to the next edge for my tangency to face. I think this one has an inflection, but I don't think we can get around that. So, oh, no, it doesn't. It doesn't have an inflection point. Sorry, it was just the perspective. Okay, so surfaces, fill surface. Let's exit the sketch first. So this edge. Oh, look at that. I'm using 2 edges. I usually try to stay away from that. We'll have to see if this would make sense to have a triangular face here, or we can go ahead and and tangency for these ones, or we can go ahead and try to have 2 edges in this direction. Let's see, without optimize, what's going to happen without optimize. Looks actually pretty good at the first sight, so we'll see. Okay, now let's go around another 3D sketch. So again, divide and conquer between these 2 points. Try to be logical about the type of edges that were created before. So here, again, I'm going to try to go to the next edge to apply my tangency. I'm doing that in the hope that when I'm going to go around, it's going to create something that is going to flow nicer around. So let's see, again, fill surface, this edge, this one, oh, and this one tangent, of course, this one, and can I select this one? Let's see. There you go. Preview looks bad, right? But we're going to turn off optimize and suddenly it's going to look beautiful. Excellent. Now, where is this edge going to go? Is it going to go all the way here? What do you guys think? Should we try that? Let's see. That's actually a pretty complex phase to do. So I'm actually going to start from the opposite direction. So let's try to create a 3D sketch containing 2 splines this time. One here and one between this, and let's see if I can pick up this point here. Okay, let's apply relations. Here I can use the edges for tangencies. Same thing here. I can use an edge. Oh, too many selections. There you go, tangent. And here, let's use, this time I'm going to use the other edge for face tangent. Okay, so surface, fill surface again. So this is going to be tangent. This is going to be tangent. Optimize or not optimize? What do you guys think? Let's try with optimize here because I want to have the directions coming in based on my selection. And now the hardest part probably would be to close this because this edge, it's wild. We might need to create something more roundish. I'm not sure if it's going to work well. So fill surface, tangency everywhere. Now, a quick tip I can give you if you want to quickly select all those edges with one go, just do a knitting beforehand. So I'm going to knit all these surfaces. And now when I run my fill surface, I can right click on any of these edges and use the option select open loop. Actually, let's do the pre-selection first. Select open loop and then run the fill surface. Now let's apply tangency to all of them. Turn off the optimize. Optimize without optimize doesn't work, so this is pretty complex. Right? So the question is this good? Is this acceptable? Well, I forgot to apply tangency to all of them, so let's apply tangency to all the edges. Preview doesn't look amazing, eh? Click OK. And in case we don't like it, okay, do we like it or not? How can we judge the quality of this surface? So there are a couple of things we can run. Zebra stripes. So across the edges, we have tangencies. But on the surface itself, that looks a little bit tortured. The other thing I can do is turning on the curvature, just looking for nice transitions in curvature. And I can also turn on the visibility of the surface curvature comps. So let me just decrease a little bit the scale and maybe use the dynamic option to simply move the curvature comps on here. So you can see some really abrupt transitions in curvature, especially across this edge. Fortunately, we can do a little bit of improvement by adding a couple more curves. So let's see, sometimes too many curves would constrain the curvature too much or the surface too much. In this case, we can try. So another 3D sketch. Let's run another spline. This time I'm going to go from here to maybe this point. Actually, I'm not sure if this point is a good one or maybe somewhere across here. Let's see. So tangency to face, and tangency to face. Okay, so we have another curve, right? So when I run my fill surface, I can force it to go through this constraint curve, giving it a bit more definition. I can see that it might actually help. Not sure about this area, but here for sure it helps. Let's turn off the optimized surface. Because really the moment you add a constraint curve, SOLIDWORKS cannot really use the optimized surface constraining. So looks a bit better. One thing I can do, I can turn on Instant 3D and pick up this sketch, try to make it visible, and try to drag the endpoints. Yeah, looks like oh, this one, sorry, this one is coincident, that's why I cannot do it. Just gonna try to drag it a little bit more on this edge. Of course, now I have to check its tangency to make sure that it's in regards to that edge, right? So 1, 2, 3, tangent to face. 1, 2, 3, tangent to face. So let's see if it's any better now. Right, so you can see now I can try to drag this surface or this spline and check to see how the surface quality changes. That's one of the good things about Instant 3D. The changes are instantaneous. Right? What would make even more sense, maybe turn on the zebra stripe and the curvature to see how this works. Okay, so we have tangency, tangency, I have tangency here. Maybe this area over there can be improved a little bit. So you can even attempt to do maybe another spline in this direction to create an edge in this direction. So there are a couple of opportunities there if you want to increase the quality in this area. So with, oh, looks really bad now, actually. Right? I can see it actually better this way. This is really, really, really bad. So whatever changes I did on dragging the point really destroyed my surface. You can see how such a small change, just a simple drag, can drastically affect the quality of the surface. Okay, leave it where it was. Again, curvature and the zebra stripes. I'm going to say this might be acceptable. I guess the designer can tell us if that would work or not. This would be like the last mile is the hardest. Let's finish up by knitting this last surface to the rest of the surface body. And let's replace these faces with the ones from the solid body. So I'm going to hide this for a moment, bring in the solid. Okay, and select the faces that you want deleted. Let me turn off the Instant 3D for a moment. So this one, 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 and this one. Let's delete all these faces. We don't need them anymore. Let's make the newly created surface body visible. So Shift Tab will do the trick. Of course, I have to, to get the correct body, not this one. And let's run knit between this surface body, this one, and this one. Create a solid. At this point, if you want to do further improvements to the blend, you have quite a few things that you can change. One is this 3D sketch. Maybe think about ways to change this area. The other one might be changing this specific edge. Do I want to come up to here somewhere? Will that give me more freedom when I'm going around this? Or think more about divide and conquer on doing smaller faces in this area. So this is very soon is going to be the object of a Power User Challenge on SOLIDWORKS forum. We'll see what our colleagues on the forums are going to come up with. Thank you.